construction? Okay, so on this construction, you should all sketch it out. And what I'm thinking is, if I were going to be on a ray, I would copy the angle. So that would be my first step. And then I would put the diagonal in, but it doesn't say where. Don't make it a rhombus because I don't want because it's not a great way to study. The rhombus would have the diagonal be a angle bisector, but that oversimplifies it, which is a bad way to prepare for a test. Austin and Max, I think you probably have work to do, right? Yeah. Okay. So just you can't actually put the diagonal in, but imagine it there, right? You're going to put your compass here and swing a diagonal arc. The diagonal could be anywhere there. So therefore, right that alone says this isn't unique. So the idea would be that you would then put the diagonal in, and then you would copy this angle up here because parallelograms have congruent alternate interior angles. And so you would end up getting this angle here being equal to this angle here. So I'm going to go through those steps, but that's the idea. So watch. I'm going to copy the angle. Okay? So that's a short chart. You just copy the angle. So I have to go over here and measure the opening. So when I do that, I'm going to then measure the opening here. And that gives me one of the angles of the parallelogram. So I'm going to put my ray that's going to contain the side here. That didn't work. Let's do that again. So the side's going to go somewhere on that green ray. Okay? Now I'm going to take my compass and I'm going to measure the length of the diagonal. So I just open up my compass, and this arc, this blue arc, is going to be where the diagonal has to hit. So I just come over here and I make a blue arc. I can put my diagonal anywhere I want. So I'm going to take my straight tool and I'm going to put this in dotted just so you keep in mind that it's my diagonal. So let's say I put it in right here, okay?
But you can make it wherever you want.
You can, but I'm going to tell you I probably would not make a problem so easy that you could do a rhombus. A better way I might state this is construct a parallelogram that's not a rhombus.
So that we just make it wherever.
So make it wherever you want.
That's not the bisector.
That's not the angle bisector. Now I have to copy this angle right here up here, because this point right here is one of my vertices, so I have to copy this angle here up here. Do you get that? Well, I have to copy this angle below the diagonal, above the diagonal, to get alternate interior angles that are congruent. So I'm going to take my compass again, and I'm going to use that same setting. You know, because it simplifies things, I'm going to use that same setting in red. I'm going to bring my compass around here and make an arc. And I'm going to measure the opening of this angle, but only to the diagonal.
Does it have to be on that one given side?
It's got to be from the vertex of the diagonal. So So, do you see? It's a little off, because I can't get it quite that, the smart board doesn't snap exactly where I want it to. Let me try one more time. So, closer. So now I'm going to come up here to this diagonal line, and I'm going to mark the angle off there. So my parallelogram, if this is one vertex, this is going to be like if it's parallelogram A, B, C, D. This is C, the opposite vertex. Do you see that? So my next side is going to be coming from the diagonal, oops, that should have been, through that new mark. Let's make that solid so you can see. So I have, so far, two parallel lines, right? And do you see right here? This is B, because I had already drawn the angle. This original line, this line here that I'm making purple, that was from the original angle. So I made the angle first.
With a green solid line.
The green solid line, I constructed congruent alternate interior angles. So this angle here is the same as this angle here. So I have A, B, C. So I have 3 of the 4 sides of the parallelogram. So I just take my compass and I mark off the length of AB. I have to figure out how long that is. And then I put it right here. Oops, I did that in the wrong place. Sorry. I have to put it right here. So can you guys see the parallelogram is long and skinny? Can you see it? It's not unique because I put the diagonal random in a random place. This last line, this one, I knew that my BC has to be the same as AB because opposite sides of a parallelogram are congruent. So I opened my compass to AB, and then I went over to C, and I swung that arc to get D. And I accidentally at first, remember I made a little mistake, so I said, oh, I don't want that, and I went back. So is that unique? No, you could do all kinds of parallelograms with that criteria. Are we good on that one? Okay. So